Welcome back. This is another benchmark corrections resource, this one on your percent benchmark. Overall, I have to say we made some great improvement on this compared to our last. So let's go through. You know the drill. Go ahead, skip ahead to the ones you need to correct. Pay attention, pause as you need, and just because you've corrected it doesn't mean you totally understand it. So if there's something you still have a question about, make sure you're consulting with your teacher. Here we go, number one. Sorry, the one got cut off. So copy and complete on a separate sheet of paper. We're going to do it right here. So 3/5, let's start there. I'm not even going to worry about the 3/5. I see the percent is 60%. I know to write a percent, 60% is 60 hundredths, which is the same as 0.60. So I'm just going to put that in. Now, I said 60% is 60 hundredths, or 60 over 100. That's going to be my key, this idea of percents are out of 100 for answering all of these. So when I look at the next column, 9/20ths, I'm not really sure what percent that is just by looking at it. So the first thing I'm going to do is convert it into hundredths. Here I know my scale factor is going to be 5. So if I multiply the bottom by 5, I multiply the top by 5, and I get 45. So here my decimal is 0.45 and I get 45%. On my next one, I see 1/5, which I could convert into hundredths, but I also say 0 and 2/10 as a decimal. I know 0 and 2/10 is the same as 0, and I can just add a 0, 20 hundredths. And if I'm back to hundredths already, I can just write it as a percent, 20%. We're going to work backwards on this last one, 75%. 75% is 75 over 100, which I can read as 75 hundredths. If I can read it correctly, I can write it as a decimal, 0 and 75 hundredths. Again, I already have it as a fraction here, but part of the directions were to reduce or simplify your fractions. Quite a few people missed this, so because I can divide by 25 over 25, or if I know quarters, I know that this is equal to 3/4. So your table should have looked like this when it was all filled in for number one. Moving on to number two, Daphne has $60 in her wallet. She spends 30% of the money in her wallet on a new shirt. How much money did she spend on the shirt? Well, she spent 30% of the money. So I'm going to write a percent statement. I just want to be clear, there are multiple ways to solve all of these problems. I'm going to use the method that is most natural for me. That does not mean it's the only way to do this. So if these examples don't match the approach you took, please refer to your notes, check where did you make your mistake, but as far as the numbers themselves, they should all work out. So I'm going to use percent statements for most of these. So I know she spent 30% of 60. Of 60. So I can rewrite this as an equation. I know 30% as a decimal is 0.3. Of means I'm multiplying or making equal groups, 30% of 60. And because you were able to use a calculator on this test, I'm not going to work out the problems. You could plug it into a calculator and you get 18. You'll see I put the dollar sign. Make sure that you are labeling all of your answers. So number two, how much money did she spend on the shirt? She spent 30% of 60, which is $18. Next one, number three, Eddie has 175 Pokemon in his Pokédex. Of the 175 Pokemon, he evolved 49 of them. What percent, so I'm looking for a percent, of the Pokemon did Eddie evolve? A few of you were asking me, well, what does evolve means? I don't know this word evolve. It actually is not really relevant to the problem. If you read this, you know he did something, we're going to say evolved is something, to 49 of them. I want to know what percent of those did he do that to. So knowing the definition of evolved is not mandatory for answering this question. So what is mandatory is understanding that there's a part that he did something to, he evolved, and it's out of the total number. So you could set this up as a ratio out of 100. The other thing we can do is just divide. So if I read this ratio right here from top to bottom, I would say 49 divided by 175. I saw as a common mistake that some people switch this and they put 175 divided by 49, so be careful of that. When you complete this, and again you could do it in your calculator, you have 0 and 28 hundredths, which, going back to the problem, it's asking for a percent, so I need to convert that into a percent, which is 28%. So it looks like Eddie evolved 28% of his Pokemon. Okay, number 4, Julian spends 15% or $4.50 of his allowance on snacks. How much was his allowance? This is a little tricky, the language piece here. When it says 15% or $4.50, they're telling you that $4.50 is 15% of his allowance. So when I think about the whole, I don't know the whole, which would be what was his whole allowance, which is what I'm trying to find, how much was his allowance. What I know is that if I take 15% of that, it's $4.50. So here I think it makes a lot of sense to think of it, again, as a percent statement. You could have done a ratio. So just if you did a ratio, it would have looked like this. $4.50 is a part of some whole, his whole allowance, and that is 15%. So you could set it up like that. If I use a percent statement, I know that 15% is, oh, sorry, moving too quickly, let me see. Let's go back. So 15% of his allowance, I'm just going to abbreviate there, is $4.50. And I already put the equal sign in. So 15% of his allowance is $4.50. That means I'm going to convert this to a decimal. 0 and 15 hundredths times whatever his allowance is. I'm going to use the variable a here, is equal to $4.50. So what I need to do is solve for a. In order to do that, I need to isolate it or get it by itself. So I'm going to do that by dividing by 0 and 15 hundredths. So I'm using the reciprocal of multiplication to divide. This equals 1. On this side, I go ahead and divide, and what I find is A, or his allowance, is equal to $30. To check your work, you could do a quick equation. 30 times 0.15, or 15%, should equal $4.50. So how much was his allowance, or Julian's allowance? $30. Right, moving on to number 5. So number 5 had a couple parts. 6 friends go out to eat. They order pizza and some soda. The total bill is $62. So right here I see some important information. They want to give a 15% tip. What should the tip be in dollars? So I'm trying to figure out how much they're actually leaving. So let me label this as part A. So they want to leave 15% of $62. So again, I'm writing my percent statement. This is what I'm trying to find. I convert my percent to a decimal. I'm multiplying. I'm making an equal group of 62. And if I plug that into my calculator, what I get is 9.3. But I'm trying to figure this out in dollars. And in dollars means that I need to write it how we think about money. So 9.3 is the same as $9.30. We don't say just 9.3. So this is my answer for part A. So moving on to part B, how much does the evening cost the group? I'm realizing that's a phrase that may not have been familiar. So when you talk about the cost of an evening, you're talking about all of your expenses or costs put together. So in this case, the expenses are the original bill, which is $62, plus the tip that they want to leave. So when I add those together, I get $71.30. So I would say that that's the cost of their evening. So moving on to C, if the group divides the cost evenly, how much will each person pay? So I take the total of the night, $71.30. I'm dividing it evenly among my 6 friends, and I pop it in my calculator, and what I get is 11.883 repeating. That 3 goes on and on and on. Now, that's not a amount you can leave as a tip. You cannot do anything past this hundredths place. So what I need to do in this case is round. So if I look to the place to the right, which would be my thousands place, this 3 right here, I realize that's less than 5. So I'm going to think about that, and I'm going to leave that as an 8. I'm going to let it be. So I accepted $11.88. A couple people did explain that this would lower your tip amount very slightly by just a couple of cents. So some people explained that they would leave $11.89 and round up, and I also accepted that as a correct answer if it was justified. So you had a couple steps here, but most of you are pretty successful on this problem. Number 6, Rosa bought an HD TV during a Black Friday sale. She paid a total, so this is the total amount she paid, including tax. If the tax rate is 11%, determine the retail price, or this is the price before the tax. This was a pretty challenging question for people. We've done problems like this. I'm thinking back, I believe it was homework 1 this trimester, problem set 2 number 8 was like this, and we went over it in class, and there's been a do now or 2 like this as well. And what makes this challenging is we know that there's some price, and I'm going to call that P, and if you have to pay for that whole thing, plus you have to pay for 11% of it. So P times 11%. And then in all, what you know is it's going to cost you $210.90. So a common mistake here is students want to find what is 11% of $210.90 and subtract that, which I believe gave you $187 and some cents. So I see why you were thinking that, but the 11% of the total would actually be more than the 11% of your retail price. So what I need to think of is I need to think of this whole section as one value. So what am I really paying? If I have to pay for the price once, a whole price, that's 100% of the price. And then I'm also paying for 11% of the price again. So in all, I'm paying for 111% of the price. And when I do pay that, I already know that it's going to be $210.90. So once I kind of think this through and set up an equation, it's easier to solve. So 111% is 1 and 11 hundredths. Some people got a little confused and put 1 and 1/10. I think the 11, they forgot that last 1, so be careful of that mistake. So 1 and 11 hundredths times the price is going to equal $210.90. Again, like a problem earlier, I'm going to use a reciprocal of multiplication, the opposite of multiplication, and I did not mean to say reciprocal, just for the clarity of this. I'm going to use the inverse of multiplication. I can multiply by the reciprocal, or I can divide, and that's divide by 1 and 11 hundredths. Here I'm going to do the same to both sides, and once you solve, you'll see that the price originally was $190. Again, you could check that back out. What is 11% of that? Add it back in, and you will get your 210 you started with. But the final answer here is the retail price was $190. Right. Going on through, we have number 7. So Christina bought some tickets to the Justin Bieber concert for $120, but she wasn't able to go. How sad. When she sold them or resold them, she marked them up to make a little money herself. How much money did she sell her tickets for? So I know it is a markup, so it's going to be 20% more than what she did. There's 2 ways you could set this up. You could think, well, what is 20% of 120, and you could solve for that, and if you do, you get, well, 0.2 times 120 is $24. So this is my markup. This is the amount of money she added to the cost, so it's not my final answer. How much did she sell them for? Well, she sold them for the original price, which is $120 plus the markup. So in all, she had to sell them for $144. The other way you could do this is, she's selling them for the total cost plus 20% more. So you could think, well, I know she's going to sell them for 120% of 120. And again, you could make this 1 and 2/10 times 120, and right away you would get your total of $144. So either way that you approach this problem, you're getting the sale price as $144. All right, number 8. Elva pays $59.50 for boots. The boots normally cost $70. What percent discount did Elva receive? So I know what was paid, I know the original, and I know what I'm trying to find is the percent discount. There's two ways that you could think about this. First as well, if I want to know the percent discount, I need to know what was the discount. So I can go ahead and I know that originally they cost $70. I'm taking away $59.50, the amount that I paid or Elva paid, and I see that the amount that was not paid was $10.50. So this is the discount. So what percent of the total is that? So I know that $10.50 is some percent of 70. So again, using a percent statement, I'm going to turn it into an equation, and that is some percent of 70. I'm going to use the inverse operation here, divide by 70, divide by 70. These cancel out, and what I get is 15%. So you're going to get 15%. This is the amount discount because 15% is this, and this $10.50 is your discount. The other thing I saw people do was they said, well, I know my part is this is the part that I'm paying. I know the whole value is this, and they just divided, which is fine. But what you get is 0.85 or 85%. The common mistake that was made was this was decided as the answer. So 85% is not the answer because 85% is the percent you paid, which is not what you're looking for. You're looking for the percent that was discounted. So if I do a quick model, I know the whole value is 100%. So if I'm paying 85%, what is the part I'm not paying? Well, that's going to be 15%. So this method would have worked setting up a division problem, but you need to know to take 85 from the total. So again, the answer here, I'll circle it in blue, or square it in blue, is 15%. All right, last but not least, 5,000 people visited a book fair in the first week. The number of visitors decreased. It went down by 10% in the second week. How many people visited the book fair in the second week? So I know that there was a decrease. So we had 500 people and it went down 10%. So what is 10% of 500? So 10% of, and I'm sorry, not 500, 5,000. 10% of 5,000, I'm going to do 0.1 times 5,000, and I do get 500. So is this my answer? No, that's the percent decrease. So 500 is 10%. That means that that is the amount it went down. So if I know that's the amount it went down, I'm still trying to figure out how many people came. So there were 5,000 people that came. It went down 500 the second week. So I'm just going to subtract to get 4,500 people attending the second week. So again, the biggest mistake here was people just left 500 as their answer, not really thinking about what that 500 represented. 500 represented the amount of people who did not come, so to figure out the people that did come, you have 4,500. So that wraps up our video here. So as you went through, if you still have questions, please identify the things you need to practice and continue to work on that, get help where you need. Use the resources that you already used throughout the unit to build your understanding. I hope you found this helpful, and I'm looking forward to seeing your corrections as well as you having the opportunity to retake this benchmark later. All right, have a great day.